Hi everyone. In this lecture, I'm going to talk about preparing Oracle Golden Gate environment. In this lecture, you should learn how to do the following: understand the roadmap to configure Oracle Golden Gate, implement the procedure to prepare an environment for Oracle Golden Gate, understand the supplemental logging options, create manager process, and understand when and how to use source definitions file. When you configure Oracle Golden Gate, you normally go through the following stages. Firstly, you prepare the environment. You need to do some steps on the source and the target databases before you configure the Golden Gate on them. Secondly, you perform initial load, which is basically copying the initial data in the source database to the target database. Thirdly, you configure the change synchronization. This is done by configuring the change capture processes. Those are the extract and the data pump processes on the source database system. You also configure the replicate process or the delivery process in the target system. I will cover the first stage in this lecture and will cover the remaining stages in the incoming lectures. Usually, before you configure the Oracle Golden Gate on an environment, you do at least the following actions. You need to study the mechanism on which the primary key values are generated by the applications. If the target database doesn't generate the primary key values, you skip this step. You also should study the NLS settings of the source and target databases and make sure they are compatible. Study the mixed case object name issues in the databases involved in your configuration. Set up a database user in the source and target databases that will be used by the Golden Gate to connect to those databases. You also have to enable the supplemental logging option in the databases. You must configure and start the manager process. If you are using an Oracle Golden Gate release prior to 12c, and if the data structure of the source database is different from the target database, you should also create the source definitions file. We will go through all those steps in this lecture. If any target database in your configuration allows inserting new records, you need to study the mechanism on which the primary key values are generated. You need to make sure that if you allow the applications in both sides to insert new records, the primary key values generated across the databases will not overlap. If duplicate values could be generated, then you must change the mechanism so that the primary key values generated across all the databases are unique. If the mechanism is based on generating automatic sequential numbers, you may consider one of the following solutions. You can make each database generate its own range of values. Another solution is to prefix or suffix the generated primary key values with a fixed character or a number that is unique to each database. NLS stands for National Language Support, and NLS settings are used in Oracle database to support the native languages and territories, local formats for date, time, numbers, and currency. Most NLS settings can be defined in multiple levels: database level, operating system, session, or at client levels. Golden Gate can be considered as a database client, and you can configure its own NLS settings in it. The most important NLS settings in a database is the character set encoding. If the character set on the source database and the character set on the target database are the same, then usually you don't have to do anything in this regard. If the character set on the databases are different, the character set of the target database must be a superset or equivalent of the character set of the source database. Equivalent means not equal, but having the same set of characters. For example, Shift JIS and EUC JB technically are not completely equal, but have the same characters in most cases. If the source tables have some Chinese data in them and the database character set is set to UTF-8, then the character set in the target side cannot be ASCII or ANSI. The same rule applies on the NLS settings in all the other levels: operating system, session, and client levels. In all database systems, object names can be stored in mixed case or uppercase. However, the rules to create or read from mixed case object names are different from a database vendor to another. For example, in Oracle database, if you do not surround the object name with double quotes when you create it, it will always be created in uppercase. Whereas in SQL Server, quoted and unquoted names are stored in mixed case. Object names can have special characters. Again, special characters that are allowed in object names are different among the database system vendors. Golden Gate supports the special characters that are shown in the slide. Some special characters are not supported by Golden Gate though. The slide is showing those unsupported characters. As a general rule, to avoid any issue that could happen because of the mixed case in the object name, always specify the object names in Golden Gate with double quote marks, as shown in the example in the slide. Golden Gate needs a database user credential to connect to a database. It is recommended to create a database user dedicated to Oracle Golden Gate. The slide is showing a table of the privileges that should be granted to the user. The privileges that are shaded in yellow in the table, they are needed in the target system. In addition to those privileges, you must run the procedure as shown in the slide as sysdba. This procedure grants the privileges needed by a user to be a Golden Gate administrator. Refer to the documentation to have a look at the privileges granted by this procedure. Oracle Golden Gate relies on the Redo logs to capture the data that it needs to replicate source transactions. To configure Golden Gate for an Oracle database, minimal supplemental logging must be enabled at the database level. And to enable the supplemental logging, the database must be running in archive log mode. Select log mode from $sign database to know if the database is running in archive log mode or not. If not, you must enable it before you proceed. To know whether the minimal supplemental logging is enabled, select Supplemental Log Data Min column from the $sign database view. Use the commands shown in the slide to enable the minimal supplemental logging in the database level and enable the forced logging mode. Forced logging mode is optional, but highly recommended. The database services required to support Oracle Golden Gate Capture and Apply must be enabled explicitly for an Oracle database. Set the database initialization parameter, enable Golden Gate replication to true using the code as shown in the slide. To configure Oracle Golden Gate, you need to enable table-level supplemental logging. But before showing you how to do that, let's see first what's the table-level supplemental logging. Table-level supplemental logging enables you to control what information should be supplemented in the logging data. Basically, for each table, you can configure table-level supplemental logging in the following levels: unconditional supplemental logging of the primary key, conditional supplemental logging of unique keys and foreign keys. In Oracle Golden Gate documentation, those columns are called scheduling columns. Unconditional supplemental logging of specific columns of the table, unconditional supplemental logging of all of the columns of the table. When you configure the unconditional supplemental logging of the primary key, you instruct the database to include the primary key values to the log whether or not the key was changed in the current operation. When you configure the second level, beside logging the primary key values, the database logs all of the column values of foreign key and unique key if at least one of them was changed in the current operation. That's why it's called conditional logging. The values of the foreign and unique keys are logged only if one of them is changed. In the next level of table supplemental logging, the database logs specific columns of the table beside the key columns. This will include the values of the columns before the update and even if the update doesn't affect those columns. Finally, you can make the database to log simply all of the columns of the table. Of course, the more you go up with levels, the more size the redo data will be. Now, the basic question is which level to use. This depends on the type of the process you're going to configure. For example, integrated replicate process requires at minimum to have unconditional supplemental logging of the primary key and the conditional supplemental logging of unique key and foreign keys. Whereas the non-integrated replicate process needs only the first level. You will learn later in the course the difference between the integrated and the non-integrated replicate process. As you go on with the course, you will learn when to use each of those levels. Please notice that this doesn't replace the database level supplemental logging, which should be enabled in all cases. Use the command add tran data followed by the table name to enable the table level supplemental logging. If you don't use any of the command options, the default behavior will be to enable unconditional supplemental logging of the primary key and the conditional supplemental logging of unique keys and foreign keys. The non-scheduling option makes the database to log only the primary key values. The all columns option makes the database to log all the column values in the table. The calls option allows you to log the values of the provided columns beside the key columns. You need to log in to the database using the dblogin command before you issue this command. You can use wildcard in defining the table names. The example in the slide is enabling the supplemental logging to all the tables in the HR schema. By the way, the syntax of the add tran data command shown in the slide is not the full syntax of the command. I'm showing here only the options that are in our concern at this stage of the course. The first example in the slide instructs the database to log only the primary key values of the employees table. Of course, the new values of the updated columns will be included, but not the before update values. This level of supplemental logging is fine for the unidirectional configuration of a non-integrated replicate. Also, you cannot do any processing in the replicate parameter file if it is based on the before value of any column. The second example in the slide enables the unconditional supplemental logging of the primary key and the conditional supplemental logging of unique keys and foreign keys. This is required for configuring the integrated replicate process. The third example enables the same supplemental logging as it is in the second example, but it adds to the log the before value of the higher date column. This value can be used for conflict resolution or for data processing in the replicate parameter file. You will learn about data conflict in a separate lecture. The last example enables supplemental logging of typically all the columns. This is easier to use, but it will increase the size of the trail files and the packets sent through the network. If you have all the application data in a single database schema, you have the option to enable the supplemental logging on the schema level. This is recommended in this case because the supplemental logging will be enabled to all the existing tables in the schema and all the tables that will be created in the schema in the future as well. This is also required if you want to configure the DDL replication in Oracle Golden Gate. The command to enable the schema level supplemental logging is add schema tran data. The supplemental logging options are the same as the options in the command add tran data that I demonstrated in the previous slide. The two examples in the slide don't have the same effect. The first example will enable the supplemental logging of existing tables, but the second example will include the future tables as well. By the way, this procedure applies only in Oracle database, and that's slightly different with other databases. For other databases, refer to the Oracle Golden Gate documentation on that specific database.